Okay, here we go with the 2018 AP number 4. Once again, a non-calculator question, which has become a calculator question. I'll read some of the info here. It says the height of a tree. Oh, let me focus. The height of a tree at time t is given by the twice differentiable function h. Just means it's going to be smooth all the way through to its second derivative, where h of t is measured in years. Selected values are given above. So the first thing it says is use the table to estimate h prime of 6. Well, h prime of 6 would be the slope at 6 exactly, but we can estimate it using fib-faba. So it's your slope. It's either instantaneous or it's fib-faba. I've got to use 2 points to do so. Doesn't matter which ones you use as long as they're close to 6. Well, here are the 2 that are close to 6, where t is 6, so I'll use those. So it's going to be equal to 7 minus 5, 11 minus 6. I just line them up top to bottom so we have them. And then if I were to simplify that, I would get 5 over 2. You can leave it as 11 minus 6 over 7 minus 5. That's fine as well. B, explain why there must be one time. Must be. As soon as I hear must be, I know it's going to be MVT. Must be one time where f prime, h prime of t equals 2 in 2 to 10. So as soon as I hear something that must be or has to exist, I'm just going to use the MVT. And to explain it, I'm just going to go by MVT. There must exist one point where fib-faba, one point, I can write C, I don't really have to, fib-faba equals f prime of C. So I have to find an interval from this problem, an interval where the average slope of the interval is 2. And I just have to find an interval in these numbers where the average slope is going to be 2. I could test things out. I could test the whole thing. I could test little pieces. I'm just going to let you know the one that ends up working is the following. I think it's 5 to 3. 5 minus 3, 6 minus 2 equals 4 over 2 equals 2. Because in this small interval, in between 5 and 3, fib-faba is 2. There has to be a point in here whose slope is also 2. So if they ask this question and it doesn't work for the whole interval, you just try a smaller interval in between to get yourself an answer. Okay, part C. It says use a trapezoidal sum with force of intervals. The formula for a trapezoid is area equals 1/2 base times the sum of the heights. Trapezoidal sum with force of intervals to the data to approximate the average height of the tree over the interval 2 to 10. Well, they're never going to ask us for average height of the tree on this test. So this problem's not going to be a question. However, they might ask us for a trapezoidal sum, which we could do. There'd be 4 rectangles. So what I always do is I just list the heights first. The first height would be 1.5 to 2. The second one would be 2 to 6. The second one would be 6 to 11. And the third one would be 11 to 15. So I'm going to do this the fast way first, then I'm going to show you the longer way. So they're all 1/2. And I have to find the base of each one. So the base of the first one is 2 to 3, which is going to be 1. The next one is 3 to 5, which is going to be 2. The next one is 5 to 7, which is going to be 2. And the last one is 7 to 10, which is going to be 3. If how I drew this trapezoid doesn't make sense, I can leave it like that or I can put it in the calculator. What I always do is I end up drawing the points on a graph. That's what we'll do for this one right here. So the points are the height at x equals 2, we have a height of 1.5. At x equals 3, we have a height of 2. I always go higher than the one that's there. At the point 5, the height is 6. At the point 7, the height is 11. I'm running out of room to go up, aren't I? And at 10, the height is 15. And then I just say draw my trapezoids. And I draw the lengths of the bases on the bottom. So this base is 1, this base is 2, 2, and 3. So now you can see where I get the 1/2 the base times the sum of the heights for my area problem. Okay, let's take a look at the last part. I'm going to shift this to the other side so I can use this nice area over here for D. Once again, D is always going to be a harder part of the problem. Let's see what we get. It says the height of the tree in meters can be modeled by the given equation. G of x equals 100x over 1 plus x. So they give me an equation for how to find the height of the tree, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, when g of x equals 50, the diameter of the tree is increasing at a rate. So now I have a rate. So the change in diameter, what symbol do you want to use for diameter? Ooh, good question. Let's go with D. Let's go with, let's go with, we'll go with that for right now. dt is increasing at a rate of 0.03 meters per year. Oh, you know what I should do? X was diameter, so this should be dx dt. Sorry about that. Dx dt is 0.03. So another way to write this statement right here is dx dt when g equals 50 equals 0.03. And that's positive because it was going up. According to this model, what is the rate of change of the height of tree with respect to time? So they want me to find dh dt when the tree is 50 meters tall, when g equals 50 meters tall. So in order to solve this problem, I need to find a relationship between height, I need to find an equation that represents the relationship between height and diameter. And that's what this equation does. Because g is height and x is diameter, I'm going to rewrite this as g equals 100x over 1 plus x. Now that I have the relation between the two, I can take the derivative of both sides. So I get dg over dt. Remember, this is all based on time. So now I'm going to use the quotient rule. This is u, this is v. So it's u prime. Derivative, which is u prime v minus uv prime over v squared. Remember, every time I took the derivative of x, I had to include the dx dt in there. So they want me to find dg dt, because dg dt when the tree is 50 meters tall. Okay, so I've got some different things I've got to figure out how to fill out in here. I don't have a spot for g. I don't have a g. I've got to find some other information. Well, first of all, I need an answer for dx dt, and sure enough, they gave that to me right here. So dg dt is going to be 100 times 0.03 times 1 plus whatever the diameter is when the height is 50. I'd have to figure that out. So what I have to do is I have to put 50 into here and see what the answer is going to be. So 1 plus x. Going to cross multiply. 50 plus 50x equals 100x. Subtract 50x. 50 equals 50x. So x equals 1. So that means when the height of the tree is 50, the diameter is 1 meter. So I can fill these numbers in. It's 100, 1.03 over 2 squared. I could put all that in my calculator and I would get an answer of 3/4 would be the answer for dg/dt. G is measured in meters because it's height, and unit of measure is year. Okay, there we go with the next problem. Very complicated related rates problem to solve on out. You have to remember to figure out which things relate to which from the beginning of the problem. Okay, good luck.